Okay, so welcome to today's class. We'll be looking at polynomial functions, or what we call as polynomials. Okay, so under polynomial functions, we have a number of concepts to cover. Okay, we are going to cover them one by one so that we understand each one of them fully. Okay, so you can see I've listed all the subtopics under polynomial functions. We're going to talk about the remainder theorem. We'll talk about the factor theorem. We're going to see how we can divide our polynomials using long division, and also we're going to learn the method of synthetic division of these polynomials. We're going to see how we can factor polynomials, okay, using what we call as the rational root test. And then from there, we'll go to how we can solve polynomial functions. So solving polynomial functions simply means finding the zeros. Okay, so we're going to see how we can actually find the zeros, and then finding these zeros will help us graph these polynomial functions. Okay, so these here are the objectives for the whole topic, the polynomial functions. Okay, but for today, we're going to look at two important concepts. We're going to look at the remainder theorem, okay, and we're also going to look at the factor theorem. Okay, so we're going to look at these two theorems today. All right, so let's start with the remainder theorem here. So we're going to start by the definition. Okay, so we know that a remainder is just something that remains when you divide a certain number with a certain number, right? So for example, if I say 10 divided by 3, okay, you'd say the answer here is that 3 into 10 is there 3 times, and then remainder what? 1. Okay, so this remainder theorem is just about the remainder. Okay, so by definition of this remainder theorem, we're going to say, given a function, let's say f of x, okay, is divided by a factor, let's say x minus a, okay, then the remainder, okay, when this factor here divides, when this function here divides this function, the remainder is going to be given by f of a. So now the question is, where do we get this a here? Okay, because here you can see this is f of x, right? And then here I've said the remainder will be given by f of a. So this a here, we just simply solve for x. So this function that you've been given here, okay, you equate it to 0, and then you solve for x. So x will just be equals to what? To a. And then in this function now that you had initially, you're going to replace the value of this x with what it is equal to, which is the a. Okay, so simply meaning that if I divide this function here, okay, by this function, then my remainder is going to be f of a. So simply meaning that, okay, if your other function was in this form, if you say my f of x is, the function is still f of x, and then let's say the other function that I want to divide with was x plus a, okay, then in this case, we're going to say that the remainder is going to be equals to f of minus a. So how do we get the minus a? We just equate this function to 0, and then we say x is equals to what? Minus a. So now here where there's x, we replace with the what? With the minus a. Okay, so that's basically the remainder theorem. So you can read this definition here and memorize it. Okay, but I'm going to go through it. So it says, if a polynomial f of x is divided by x minus a, okay, so here it will not always be x minus a, as you see. You can also even use x plus a if you want, okay, but they just use x minus a because it is simpler. It's just going to give you a there and not minus a. Okay, so if a polynomial f of x is divided by x minus a, then the remainder will be given by f of a. And I've shown you how you can find the f of a there. Okay, so when such a question comes, maybe in the test or in the exams, okay, you can divide it in any way that you want, okay, as long as the meaning is the same. So you can say, if a polynomial, let's say h of x, okay, you can even change the letters that I use, is divided, okay, by, you say x minus maybe c, Okay, then the remainder is just going to be equals to h of what? C. So I'm trying to give it in different ways so that you just get the main concept. Okay. All right. So now let's look at an example under remainder theorem. So this is the example one here. So the definition is here to help us solve this question here. So here they're saying, find the remainder when this polynomial here, okay, is divided by x minus 2. Okay. Find the remainder when this polynomial here is divided by x minus 2. So we're just going to get the x minus 2 and then equate it to 0 and then say x is equals to, the minus 2 goes to the other side. So x is equals to 2. And then now in this function here, okay, the remainder will be when we substitute each of those x, of these x's that we can see there, we substitute them with the 2. Then we are going to get the remainder. So I'm going to say my remainder is simply equals to f of, where there's x here, I put what? 2. So this will be equals to, wherever there's x here, I'm going to be putting 2. So that will be 2, and then 2 to the power 3 minus 3, and then 2 to the power 2, and then plus 4 multiplied by 2, and then plus 5. So this is just going to be equals to 2. And then inside the brackets here, this is 2 power 3. So meaning 2 multiplied by 2 multiplied by 2. So this here gives me 8. So I have 8 there, and then minus 3, 2 to the power 2. That is 2 multiplied by 2, which will just give me 4. So that will be 4. And then 4 multiplied by 2, that will just be what? 8. And then plus 5. So meaning that I'm just going to have 16 minus 12 plus 8 plus 5, that is 13. So this here will just simply be 16 minus 12 plus 13, that will be plus 1. And my remainder is simply going to be what? 17. Okay, so any questions there on how we found the remainder using the theorem? Any question? Okay, so there are no questions. So this method that we've used to find the remainder, okay, is method 1. Okay, there are other 2 methods where we use long division and synthetic division. Okay, so this one here we use the remainder theorem, and it's the simplest. So if such a question comes in the exam, just use the remainder theorem because it's the simplest to find the remainder. Okay, you just get the function that you're dividing with, equate it to 0, okay, and then solve for x. So now the important thing is that the factor that you're, the function that you're dividing with here should be a linear function. Okay, so meaning the highest power on x should be 1. So like the way it is there, then you are good to go. So this is method 1 that we've used here. Okay, some books, in some books, they'll call it method 2. In some books, they'll call it method 3. But it doesn't matter as long as you know the method. Okay, so this is one of the methods that we can use to find the remainder. And then I said there are other 2. Okay, so let's try to look at the other 2. So the other 2, we have the synthetic division method and we have the long division method. So I'll start with the long division method. So for example, if I'm given f of x here, okay, f of x is being divided by, let's say g of x. So to use long division method to find the remainder, I'm just going to write this symbol for division, you remember it, and then you put the function you're dividing with here. So the g of x will be there, and then you put your f of x here. So now the secret to the long division is that this function here, the f of x that you're putting here, okay, the powers on the x should be dropping down smoothly, or they should be reducing by 1. So meaning that if in that polynomial, okay, your highest power of x is 4, the next item here should have x power 3. Okay, so it should be plus maybe 2x to the power 3 plus, and then x power 2, and then plus maybe 5x, and then plus 7. So you can see the powers here of this x. They are dropping down smoothly, or they are reducing by what? By 1, because this x here is the same as power 1. And then this one here without the x, the same as x to the power 0. So you see the powers are dropping down smoothly like that. So if it happens that they give you a polynomial, okay, that has some missing powers of x, then you have to put placeholders for those missing powers of x. So for example, if maybe your f of x was given as, let's say x to the power 4, and then they say plus 2x. So you see that from power 4, we've gone to power 1. So it means they are missing what? Powers there. So when writing this polynomial under this division symbol, you have to make sure that all the powers appear. So you put x, the coefficient of the this x, I mean you put this x power 4 and then plus. Since we don't have the x power 3, you're just going to write 0x to the power 3 and then plus 0x squared. And then now you write this one. Okay, so that's the secret of whatever we are going to be putting under there. Okay, so long division is the same thing that you're doing in grade 5, but just a little bit complex because we are dealing with polynomials now. So in this case here, this is my f of x, and then I'm dividing with this. So this is my g of x. Okay, so I'm going to say using long division, let's find the remainder. So this guy, the polynomial, goes under here. So I said the power should be dropping down smoothly. It's happening, so that's good. So you put 2x to the power 3 minus 3x squared, and then plus 4x plus 5. Okay, and then here the g of x is simply x minus what? 2. Okay, so now the way we divide when we are dealing with polynomials, we divide one by one or term by term. Okay, you don't expect yourself to say x minus 2 into this and then you find the answer. No. So you just get the guy here, the guy with the x. So you say this x here, I divide it into 2x to the power 3. Okay, so x into 2x to the power 3 here is the same as 2x to the power 3 divided by x. So what do I get here? I'm just going to get 2x squared. So I'm going to write on top of this guy here, 2x squared. Okay, and then once you have that, you're going to multiply this answer here with this whole function here. So I'm going to say 2x squared multiplied by x. I get 2x to the power 3. And then 2x squared multiplied by minus 2. I get minus 4x squared. Okay, and then once you are done multiplying, you're just going to write a line here and then you say minus. Okay, so what are we subtracting? These guys with the x power 3 and these guys with the x power 2. So 2x power 3 minus 2x power 3, this will be 0. And then here, careful with the negative signs. So it's minus 3. So I'll write it down here. Minus 3x squared. And then minus here. And then minus 4x squared. So always be careful with the signs. Okay. It's better you write it on the side like this and then you find. Okay. So this will be minus 3x squared. And then negative multiplied by negative. That will be plus. And then 4x squared. So you see here, this is just the same as 4x squared minus 3x squared, which will just be what? X squared. So here I'm just going to write plus x squared. Okay, and then once you do that, you are going to bring down this guy here. So you remember the bring down that you're doing in grade, I don't know if it's grade 3 or 4. So you're going to bring down this guy. So that will be plus 4x. Once you bring down this guy, you divide again by this x. So x divided into x squared. Okay, that's the same as x squared divided by x. This is just going to give me x. So I write the x on top here. So it will be plus x. And then now I multiply that x with this whole function here. So that will be x multiplied by x. That will be x squared. X multiplied by minus 2. That will be minus 2x. And then I draw a line there. And then I say minus. So now I'm subtracting these guys here. So it will be x squared minus x squared. That will be 0. And then 4x minus 2x. So always be careful. So that's the same as 4x minus 2x. So that will be 4x plus 2x. So that will just end up giving me what? Just end up giving me positive 6x. Okay. Once you find that, you bring down the 5. So that will be plus 5 there. And then you say x into 6x. So that will just be plus 6. And then this 6 multiplied by the x, I get 6x. And then 6 multiplied by minus 2. So that will be minus 12 like that. Okay, that will be minus 12 like that. And then from there, you're just going to subtract there. Okay, so let me just move this a bit up like this. Okay, so here we're going to say here we're subtracting again. So this is 6x minus 6x, 0. And then 5 minus minus 12. So that is 5 minus minus 12. So that will just give me 17. So that is 17. So now can x go into 17? The answer is no. Okay, because it doesn't have any x. So it means this guy here is our what? Is our remainder. Okay, so you see that the remainder that we got using the factor theorem, okay, and the remainder that we are getting using the long division method, they're the same things, 17, 17. Okay, so any questions here on how we got the remainder here using the long division method? Any questions there? Okay, so if there are no questions, then this is method 2. So you can use long division to find the remainder, okay? But we'll have a class where we'll talk about long division to length. Okay, so I'm just telling you the methods here. So the other method that we can use here is what we call as synthetic division. Okay, synthetic division. So we can use synthetic division to actually find the remainder here. So synthetic division only concentrates on the coefficients of the polynomial that you have. So I'm going to write the division symbol here. Okay, so there are a number of ways in which you do synthetic division, but the principle is the same. You're just going to use addition and multiplication. So in long division, you are using division and subtraction. Okay, and then in synthetic division, you're using addition and multiplication. That's the difference. So here, okay, I'll just get the coefficients of these x or I would just get the coefficients in this in this polynomial here. So the coefficients are these numbers in front of the x power something. These are the coefficients, okay? So this one, the 5, it's 5x to the power 0. Okay, so it's also a coefficient. So I'll write the coefficients. So make sure always that the coefficients are from a polynomial that is dropping down smoothly, okay, or where the powers are reducing by 1. So for this one, it is 2, and then I go minus 3, and then I go 4, and then I go 5. And then this guy now that is dividing, I'm going to equate it to 0, and so for x. So x here is going to be equals to 2. So I'll put 2 here. Okay. So the first thing now, I'll draw a line here, and then I'm going to bring down the 2 there. Then here I'm going to put a positive sign. Okay. So it will be, I bring down the 2, and then I said 2 multiplied by 2. I'll get 4. 4, you put it there. Then here you're going to add. Okay. So 4 plus minus 3, that would be 1. Then 2 multiplied by 2, 2 multiplied by 2, you're going to have what? 2. And then here you're adding 4 plus 2, that would be what? That would be 6, right? And then 2 multiplied by 6, that would be 12. And then 5 plus 12, that would be 17. So the last number that you get here is always your remainder. Okay, so this is the remainder here. So you see that long division, synthetic division, and the remainder theorem, they are all giving us the same remainder. Okay, so it's up to you to choose. So unless a question specifies that use synthetic division or use long division to find the remainder, that's when you can use these methods. Okay, but if it just says find the remainder, then you have to use the remainder theorem because it's the easiest and the fastest. Okay, so any questions there, guys? Any questions that you have? Okay, so no questions. Let's look at another example under remainder theorem. So this one here, they're saying if the remainder, when this polynomial here is divided by x plus 1 is 8, find the value of k. Okay, so we're just going to use the remainder theorem here. So we're dividing by x plus 1. So I'm going to say x plus 1 is equals to 0. So that will be x is equals to minus 1. Okay, and then I'm going to find f of minus 1 is equals to minus 1 to the power 4 plus 3 minus 1 to the power 3 plus k, then minus 1 squared plus 2, then minus 1 and then minus 1. So this will just be minus 1 to the power 4. So as long as the power here is an even number and then you have a negative number here, you are going to get a positive number. So this is the same as minus 1 multiplied by minus 1 multiplied by minus 1 multiplied by minus 1. So you're just going to get 1. So minus 1 to the power 4 is 1. And then plus this minus 1 to the power 3, that would be negative 1. Then negative 1 multiplied by 3, that would be minus 3. And then plus here minus 1 to the power 2, that would be 1, positive 1. And then positive 1 multiplied by the k, that would be k. And then 2 multiplied by minus 1, that would be minus 2. And then this will be minus 1. So that is what we have there. So now we can combine. So this is f of minus 1 is equals to, so I have 1 minus 3 minus 2 minus 1. So this positive 1 and the minus 1 cancels out. So I only remain with the minus 3 and the minus 2, which give me minus 5, and then plus 5. So now, you remember we were told that when this guy divides this, the remainder is what? 8. So it means f of minus 1 here is equals to 8, because the remainder is 8. Okay, so this f of minus 1 is just 8 is equals to minus 5 plus k. So this means k will just be equals to 8, and then this minus 5 comes to the other side, so that would be plus 5, and this will just be equals to what? To 13. So the value of k there is 13, and we found it using the remainder theorem. Okay, so any questions there? Any questions there? Okay, you guys are too quiet. Mzani Vesaldeska should be participating. So, yeah, so that's basically the remainder theorem. So all the questions that you will be asked to find under the remainder theorem, as long as you know the definition there and how to apply it, you are good to go. Okay? Any questions that comes there, you'll be able to solve it. So we move on to the next one, which is the factor theorem. Okay, so the factor theorem is just an extension of the remainder theorem. Okay, so remember for the remainder theorem, we said that f of x, okay, we said that if f of x is a polynomial, right, and then I have a function x minus a, then we said the remainder would be equals to f of a, right? That's what we said under the remainder theorem. So when you come to the factor theorem, it's basically the same definition, but here, the remainder here is just going to be what? To be 0. Okay? So the factor theorem states that, okay, x minus a, okay, is a factor of f of x if and only if f of a is equals to 0. Okay? So a factor, in other words, okay, a factor is simply a number that you divide into a number and your remainder is going to be 0. So for example, 10 divided by 5, the answer here is just 2. The remainder is equals to 0 because 5 goes into 10 exactly 2 times. So the remainder is 0. Okay. So any number like this 5 here, okay, that goes into another number, okay, leaving a remainder of 0, then that number is going to be a factor of the other number that is dividing. So here we're going to say 5 is a factor of 10. Okay, 5 is a factor of 10. Why? Because when I divide 10 by 5, I get 2 and my remainder is 0. Okay, so when the remainder is 0, then we say that what we were dividing with is a factor of what we divided by. Okay, so that's the thing there. So the factor theorem is just an extension of the remainder theorem. So meaning that the remainder is just going to be 0. Okay, so you can state it mathematically like this. You can say the factor theorem states that, okay, if x minus a is a factor of f of x, okay, if and only if f of a is equals to 0. Okay, so what is happening here is basically the same. You are going to get whatever you are saying at it is your factor, x minus a. You're going to equate it to 0, and then you solve for x. So that will be x is equals to a. And then if it is a factor of f of x, then f of, when I replace this x with the a, okay, because they are equal, it should be equals to what? To 0. Okay, that's what it means. So x minus a is a factor of f of x if and only if f of a is equals to 0. Okay, but what if my factor was x plus a? How would my definition change? Okay, so we're going to say f plus a is a factor, okay, of f of x if and only if f of minus a is equals to 0. So where did I get the minus a here? I equated this guy to 0, so x plus a is equals to 0, and then x is equals to minus a. So here where there's x, I can replace with the minus a because they are equal here. Okay, so that's the factor theorem. So in short, just an extension of the remainder theorem, but here specifically that the remainder is just going to be 0. Okay, because remember, under the remainder theorem here, we said the remainder was f of a, right? But under the factor, we're saying the f of a is equals to 0. So simply meaning that the remainder is 0. Okay, so in case you you forget the definition of the factor theorem, and then you remember the factor of the remainder theorem, you can actually use that same definition, but just say that the remainder will be 0 for the factor what? Theorem. Okay, so now let's look at how we can use this factor theorem. So we have example 1 here. So the first example here, they're saying, show that x minus 1 is a factor of this function here. Okay, so what do you think we do? Okay, we just first equate x minus 1 to 0. So for x, we're going to get 1. Okay, so if this guy is a factor, then f of 1 should be equals to 0. So let's try to see if f of 1 will be equals to 0. If it is equals to 0, then we confirm that this is a factor. If it is not equals to 0, then we're going to say this guy is not a factor. So f of 1 is equals to 2, 1 to the power 3 minus 1 squared minus 4, 1, and then plus 3. So this will just be 2 minus 1 minus 4 plus 3. So I can see 2 plus 3, that is 5, minus 1 and minus 4, that is minus 5. So this is equals to 0. Okay, so you see that f of 1 is equals to 0. And this one here came from this factor. So it means this guy here is indeed a factor of this. Okay, so that's the factor theorem there. Okay, so we can also ask ourselves, is x plus 1 a factor? Okay, so we first equate x plus 1 to 0. So for x, this will be minus 1. So let me try to find f of minus 1. If this is equals to 0, then I'm going to conclude that x plus 1 is also a factor. If it's not equals to 0, then it won't be a factor. So let's try to find. So f of minus 1 will be equals to 2 minus 1 to the power 3 minus, where there's x, I put minus 1, and then squared minus 4, where there's x minus 1, and then plus 3. So this here will just be equals to minus 1 to the power 3, that will be minus 1, multiplied by 2, that will be minus 2. Here, I'll get minus 1, because minus 1 squared will still be a positive, and then minus 4 multiplied by minus 1, that will be plus 4, and then plus 3. So this one here, this gives me 7. This one here gives me minus 3. So the answer here is 4. So f of minus 1 is equals to 4, and this is not equal to what? To 0. So meaning that this factor here that I put here is not a factor. Okay, it's not a factor. So that's basically what we're going to be doing under what? The factor theorem. Okay, so any questions there before we look at another example? Okay, so let's look at example 4. So here they're saying if x plus 2 divides exactly this guy here, find the value of p. So what do they mean by the word divides exactly? Okay, so divides exactly, they are simply meaning that this guy here is a factor of this guy, because if it divides exactly, then the remainder will be 0. Okay, so first of all, I'm going to get the x plus 2, equate it to 0, and then this will be x is equals to what? Minus 2. Okay, And then now, since this guy divides exactly, then it means that f of this x, which is minus 2, should be equals to what? Should be equals to 0. So that's how we're going to find the value of p. So I'm going to say here, it will be f of minus 2 is equals to, f of minus 2 is equals to, this is x, which is minus 2 to the power 4, and then plus p, and then this one here is minus 2 to the power 3 minus 2, and then squared, and then plus 2. So this will be equals to, we know that f of minus 2 here is equals to 0 because this guy here divides exactly. Okay, so this will be 0, and then minus 2 to the power 4, that would be 16. Okay, minus 2 to the power 4, that would be 16. So I'm just going to write there 16. And then here, minus 2 to the power 3, this is an odd power, so this will be minus 8. So that would be minus 8p. And then here it will be minus 2 to the power 2, that would be 4. So that would be minus 4 plus 2. So this will be 0 is equals to 16 minus 8p minus 4, and then plus 2. So this will be what now? So this will be 0 is equals to 16 minus 4 plus 2. So that's the same as 16 plus 2, that would be 18, and then minus 4, this will be 14. So I have 14 minus 80p. Okay, so I want to find the value of p. So I can get the minus 8p to the other side. So that would be minus positive 8p is equals to 14. Divide both sides by 8. That would be p is equals to 14 over 8. And this will just be, divide 2 there, 7. Divide 2 here, that would be 4. So the value of p is actually 7 over 4. Okay, so any questions there? Okay, so if there are no questions, let's look at an examination example under factor and remainder theorem. Okay, so pay attention to this because most likely such a question can come. So Chanda, you're writing on my board. Let me just cancel the annotations here. Disable annotations. Okay. Okay, so let's look at this last example in this class, which is an exam question. Okay, so this one says what now? Okay, so this one says the polynomial f of x is equals to a x squared plus bx plus 2 is divisible by x minus 2. What do they mean is divisible? They mean the remainder is equals to 0. That's what they mean by divisible by this. Okay, another polynomial p of x given by bx squared plus ax plus 1, okay, has a remainder of minus 15. So they're saying the remainder is minus 15 when divided by x minus 2. Find the values of a and b. Okay, so how can you use the remainder and the factor theorem to find this? Okay, so we start with the factor theorem. So here they said I have this polynomial here, and then I have this function here. And when I divide this function into this, the remainder is 0. So when I get this function x minus 2 equates to 0, x is going to be equals to 2. So meaning that, okay, since the remainder is 0 here, it means that f of 2 is going to be equals to 0. Okay, so here f of 2 is going to be 0 is equals to, so since this is the f of 2, wherever there's x, I'm putting 2. So that is a 2 squared plus b, where there's x there, I put 2, and then plus 2. So this will be 0 is equals to 2 squared, that would be 4a plus 2b plus 2. So meaning I can take the 2 to the other side. So that would be minus 2 is equals to 4a plus 2b. And then I can divide both sides by 2, this side by 2, this side by 2. So I get minus 1 is equals to 2a plus b. Okay, so that there will be my equation 1. So my equation 1 will be 2a plus b is equals to minus 1. Okay, where did we get this equation? We used the factor theorem. Okay, so now we go to the second part where we are using the remainder theorem to come up with an equation again. This one here. So here they said if I divide this guy by this, my remainder is this. So I get this x minus 2, I equate to 0. So x will just be equals to 2. So they are said the remainder is 2, is minus 15, I mean. So meaning that p of 2, okay, is equals to minus 15. That's what they mean, okay, because it's the remainder. So here now I'm going to say p of 2 is minus 15 is equals to, wherever there's x, I'm putting 2, okay, plus a 2 plus 1. So this will be minus 15 is equals to 4b plus 2a plus 1. So this 1 goes to the other side. So it will be minus 1 minus 15. That will be minus 16 is equals to 4b plus 2a. Then I can divide both sides by 2 like that. So here I'm just going to get minus 8 is equals to 2b. And then here I'm going to get plus a. So my second equation is simply a plus 2b is equals to minus 8. Okay, so that is my second equation. Remember, the question was about finding the values of a and b. So we can now solve those two equations using simultaneous equations. So simultaneous equation, we have a lot of method. We can use substitution, elimination, whatever method. So let's use substitution. So from here, I'm going to say a is equals to minus 8 minus 2b. And then I'm going to replace it in the first equation there. So that would be 2. Where there's a, I put minus 8 minus 2b. This whole thing here represents this a. And then plus b is equals to minus 1. So this will be minus 16 minus 4b plus b is equals to minus 1. So this here will be minus 16 minus 3b is equals to minus 1. And I can take this minus 3b to the other side. So that would be minus 16. This one comes the other side. So that would be plus 1 is equals to 3b. So this will be minus 15 is equals to 3b. Divide by 3, divide by 3. My b will simply be equals to minus 5. Okay, so that's how we can find the b. And then to find the a, we're just going to use that equation that we came up with. So we said a was equals to minus 8 minus 2. The b there was minus 5. So this is minus 8 minus 2 multiplied by minus 5. That will be plus 10. And this will just be 2. So the values of a and b is that a is equals to 2 and b is equals to minus 5. Okay, so any questions there? So this is an example of an exam question. Okay, so any questions there, guys? Any questions on the factor and the remainder theorem? Okay, so if there are no questions, that was the class for today. We're done. We've covered the factor and the remainder theorem. Next time we have math, we're going to look at long division in details and synthetic division. Okay, so I've put an assignment for you guys here. You can screenshot and you can try out these questions here. So it's the same thing that we are doing. Okay, it's the same thing that we are doing. So the question says use the following to find the remainder. Okay, so you use long division to find the remainder, synthetic division, the remainder theorem. So here, okay, this is the first one here. So you use long division, synthetic division, and the remainder theorem to find the remainder here. Okay, so this is a very simple assignment that I've given you. So screenshot it, and I'm also going to share a picture in the group. All right, so any other questions, guys, before we end this class? Okay, so those who'd like to register for our classes, you're welcome to register. You can just go on Google and search discretelearning.com our website is going to come up. We have a lot of lessons for all the topics that you are going to cover. Yeah, in NS. So math, chemistry, physics, biology, we have lessons for all that. So let me show you the website. So you can just go to Chrome like this, and then you type in discretelearning.com, and then you go to the website. Okay, so once you go to the website, this is the website here. So this is how it looks. So you can see the courses are there. So math, chemistry, physics, biology. So you can register for any of these courses and be learning at your own pace. Okay, at your own pace. So for example, if you go in math, so we are doing math, right? We are doing what were you doing? Remainder theorem, factor theorem. We already did those things, and full videos are there that you can use to learn. And we also have tutorial sheets and past paper. So you can open this course, mathematics, okay? And then you go in the general mathematics folder. Okay, unless you are from Apex, you go here. If you're from Unilas, you go in those folders. Okay, but if you're from any other university, Mukua, CBU, UNZA, any other university, you go in general mathematics. So you open the general mathematics folder. Okay, you're going to find topic lessons, summarized notes, tutorial sheets, past quiz, test, and exam papers. Okay, so in here, there are tutorial sheets. They are solved in video form. Here, there are past quiz, test, and exam papers solved in video form, well explained for you to learn at your own time. Here, there are summarized notes. Okay, and then here, topic lessons. Let me show you. So when you go to the topic lessons, they are well arranged, okay, from sets all the way to uh, introduction to statistics. Okay, that is if at your university you go all the way up to introduction to statistics. So for example, we're doing polynomial functions. So I can go to this folder, polynomial functions. So let me open this folder you see. So when you go in this folder, which is polynomial functions, you can see there are a lot of videos here. So factor and remainder theorem of what we are looking at, there's already a video there and another video and another video. Okay, how to solve polynomials, how to factor, it's there. Okay, how to factorize polynomials, it's there. How to divide polynomials using long division, it's already there. Divide using synthetic division, it's already there. Okay, how to solve polynomials, find their zeros, and sketch the polynomials. The videos are already there. Okay, so make sure you register on our website. You start learning at your own time, at your own pace. Okay, so if you want to get in touch with me, okay, you can contact me on 0779 96 40 and then 10. Okay, so that is Tutor Pro Solutions. All right, but if you just want to register on your own, okay, you can just check the link in the description below here. You are going to find a link, okay, to the registration of video guide. Okay, so you watch that video is to tell you how you can register, make an account, and access all this that you're seeing here. Okay, and it also has the link to our mobile app. So on our mobile app, when you go to Play Store, just search Discrete Learning Institute. So that app allows you to download the videos and watch them offline. Okay, so even in your blankets, you're able to learn. Okay, so you can download the videos in advance when you go to a place where there's Wi-Fi, and then you learn at your own time uh, when you're offline. Okay, so download the videos on the app and then watch them uh, when you're offline. All right, so thank you so much for watching. This has been Tutor Solutions. Until next time, always there for you.